Hello. In this project, I will present a machine learning solution to predict customer churn in a subscription-based service, such as a streaming platform or a telecommunications company. The customer churn refers to when users cancel their subscription. This is an important problem because acquiring new customers is usually more expensive than retaining existing ones. Machine learning is a good solution for this problem for three main reasons. First, there is a large amount of historical data available, such as user activity, subscription history, customer support interactions, and payments behaviors. And second, the patterns in the data can indicate when the customer is likely to leave. For example, reduce usage frequent complaints or payment issues. And third, predictions can directly influence business decisions. If we can predict which customers are likely to churn, companies can offer targeted promotions or support to retain them. Therefore, predicting churn represents a strong opportunity for a machine learning application because it has a clear business value and available data. On the CRISP-DM business understanding, the main objective is to predict whether a customer is likely to cancel their subscription in the near future. The model would output a variability score or probability score indicating the likelihood of a churn for each customer. From a business perspective, success would mean that the company can identify high-risk customers early and take actions to retain them. Some possible outcome metrics can be reduction in churn rate, increased customer retention, or the higher customer lifetime value. For evaluating the machine learning model itself, we could use metrics as accuracy, precision, recall, etc. Many factors can influence the churn prediction, and these factors may be frequency of service usage, the number of customer support interactions, payment delays, subscription duration, and customer demographics. On the solution validation plan, the proposed solution is a supervised machine learning classification model that predicts whether the customer will churn or not. To validate the solution, we would conduct several experiments. First, we would split the dataset into training, validation, and test sets, and then we would test different machine learning models. The machine learning models to be tested would be logistic regressions, random forest, and gradient boosting. We could compare the performance of the base models using evaluation metrics, and additionally, we could run A/B tests in production. For example, the system would identify high-risk customers, and some of them would receive retention offers while others would not. This could allow us to measure whether the model actually helps to reduce the churn. On the machine learning system design, there are several important system design decisions in the machine learning system. The first would be batch or real-time predictions. In this case, batch predictions would likely be sufficient. The model could run daily or weekly to identify customer at risk of churn. The second would be the training pipeline automation. The system should periodically retrain the model using new customer data so that predictions remain accurate as customer behavior evolves. On third, the model monitoring. Once deployed, the system should monitor prediction accuracy and detect issues such as data drift or changes in customer behavior that could affect the performance. This would ensure that the model continues to perform well over time. To conclude, the potential risks in production would be several potential risks that could affect the model. One risk is data drift, where distribution of input data changes over time. For example, customer usage behavior may change due to the new features on the market trends. Another risk is concept drift, where the relationship between the input features and churn rate changes. For instance, a factor that used to indicate churn may no longer be relevant. There would be also training serving skew, where data used during the training differs from the data available during the prediction. To address these risks, the system should include monitoring tools to detect performance degradation and trigger retraining when necessary. That is all. Thank you.